For the diode circuit shown, we're asked what will the output voltage, Vout, be in volts if our input voltage, which is the V, is a sine wave with an amplitude equal to 1.6 volts. We can assume that the diode is turned on if the voltage across it will be 0.7 volts. So we're going to look at the notes linked below the like button about page 61, 62. We have our peak detector circuit, and we're going to use this graph here. So diodes are often used to create peak detector circuits. This is very similar to what we have here. They output the maximum peak value of an integer value. When V input goes positive, the diode turns on, and it's going to charge our capacitance to our VP. The peak value VI is the ideal diodes assumed here for simplicity. We're going to be dealing with non-ideal diodes, and that is where the 0.7 volts comes in. The capacitance will start charging through the input once the voltage input is greater than our 0.7 volts. And this again is for non-ideal diodes, because if it's ideal, then we're assuming that the voltage across it is 0. And we can put that here as well. Ideal diode equals voltage, or the voltage across it equals 0. So that's just a little important distinguishing to note. When V input drops from the peak value, the diode is going to turn off, and the C state, which is the capacitance state, charge to our VP until a load or leak current is going to discharge it, and that's the down part of this graph. So if we were to make our own graph, it would look something like this, right? And we have a 0 right here, and we need to draw our graph. So we're going to have these values like this. Well, this again is for a ideal diode where it's at 0, but notice it's not at 0. We're assuming the diode is turned on and the voltage across it is 0.7 volts. So this should be 0.7 volts right here. If we wanted to continue the graph down, we could say that like this would be like a 0 here, right? It turns on at 0.7. But it's important to note the difference because the amplitude, right, our sine wave amplitude is at 1.6 volts. So even though it's at 0.7 volts, it's still, like for the entire graph, going to start at 0 volts. So if it turns on after 0.7 volts, that means that we are going to start a little bit later. Like right here is where 0.7 is. And so our voltage output, if we look at this, it was going to be like right here, like how we have it up here. This is our VO, which is what we want to find. What will the output voltage be? Well, it's going to be the difference of this right here. And we know that our peak, the sine wave with the amplitude, sorry, not peak, but amplitude is equal to 1.6 volts. And amplitude is just the value from here to here. And for our problem, it's 1.6 volts. This is amplitude. And so what we're going to do to find the green value, that's what we want, where our V output is, we're going to take our voltage input minus the voltage of the diode. And so this is going to be basically a 1.6 minus 0.7, and this is going to give us a 0.9 volts. And that is the answer to this problem and how we would go about looking at it.